In the name of Allah, the Compassionate and the Merciful. Hello guys. In this video, we're going to have an example about pushover analysis of this column based on force analysis method with force control, the beam based on Timoshenko beam theory in C programming. As you see, we have 6 degree of freedom elements, and just you see in here degree of freedom number 5 we have unrestrained conditions and 2 hinges as a moment rotation and shear deformation hinges available in here. You see in here, and in here we have moment rotation hinge, and in here we use the shear deformation. So I modeled this example as a book. Let's see the book. Yes, you see in here Theory of Nonlinear Structural Analysis book, and we wanna model it like these structures as a concrete column with incremental applied loads in degree of freedom number 4 with moment rotation and shear deformation as a torque you see in here, and use the Timoshenko matrix form for calculating of internal forces, you see, based on force analysis method. You can see all the examples which are very needed and very helpful for structural engineers to learning nonlinearity. This book, Theory of Nonlinear Structural Analysis, are recommended to see and trying to solve the examples even in Excel or MATLAB. So let's see the code. You see in that code we are going to define 3 types of input data. The first, we define the moment inertia, area, shear area, elasticity modulus of this concrete section, Poisson ratios, external incremental forces, and number of increments for applying the pushover analysis. Let's see the other input data. We use the coordinates in here, and the second for our second data, and for our third data we use the moment rotation and shear deformation data. We all import all data as a CSV file. After importing all data and checking if the data is incorrect, in here all data is going to be checked, and after all the steps we use this function as an analysis function for importing all data which are needed for our modeling and trying to model it. And analysis is going to be started. You see, for example, in here in stage 1, when there is no plastic hinge, we're going to have an incremental force, and checking the stiffness matrix, inverse it and trying to solve it to catching the internal forces in here, you see, and trying to output our internal forces, and also the displacement and base shear, and you see in here, and it checks the if in moment or shear we got the plastic hinge in any coordinates, and in second stage we see if the plastic hinge is accurate in stage 1, then the conditions is checked, and we define it renew with the new plastic hinge and new modeling it, you see in here. And then after analyzing and checking the data, we check the if the moment or shear reached to the yield, you see. And in third stage we use again incremental forces with changing the stiffness matrix based on new plastic hinge or shear deformation which are accurate in any coordinate, you see. And you see in here we're going to check it again and outputting our data. Yeah, that's all. And many functions which are available for our analysis is needed. For example, checking the plastic hinge stiffness in here, or plastic hinge stiffness coefficient in here. And let's see. After running the analysis, you see all input data is shown based on the element properties. We're applying loads, incremental, the number of increments, coordinates, moment rotations based on a moment rotation, and plastic hinge of shear deformations data which are needed for our modeling of plastic hinge, and also the analysis report based on each increment forces which are applied. And you see in here our input data as input data, all element properties and incremental forces, coordinates, and you see the moment rotation and shear deformation data in here. And also after running the analysis, we export our data as a CSV file, as Excel, and even in HTML, and also as a HTML graph for better showing our base shear and displacement graph. Thanks guys, I'd be glad to know your opinion about my modeling. Bye.